Good morning, children. Let us start the new lesson. Our new lesson name is solids, liquids, and gases. So, what we are going to read in this lesson, let us see. In this chapter, you will learn about the definition of the three different states of matter, the difference between atoms and molecules, the solubility of solids, liquids, and gases in water, the difference between the physical changes and the chemical changes. Okay. So, what is the definition of the three different states of matter? What are the three different states of matter? This you might have learned in your fourth class also. Okay. So, what is the three different states of matter? Yes, they are solids, liquids, and gases. So, next, what is the difference between the atoms and molecules? What are the atoms? What are the molecules? And the solubility of solids, liquids, and gases in water. How the solids will change, okay, when they are mixed in the water. How the volume of the liquid changes, and gases in water. So how they act in water when they are mixed in the water, how they respond, that is. And the difference between the physical changes and chemical changes. So what is the physical change, what is the chemical change, all that we are going to read now. Okay. So first let us see what is the matter. The world is beautiful place. The things you see around are either natural or man-made. Some things are big. An elephant is big. Some are small pebbles are small. And we see some things only with the help of the microscope. Bacteria and virus and with the help of the microscope. Okay. So some things are big in nature and some are small. Okay. For example, the elephant, it is a very big land animal, we'll say. And pebbles, you know the pebbles, we play with the pebbles, no? What you say in Telugu, Golilu. So that is pebbles. They are small and the small stones. Okay. They we see something only with the help of a microscope. And bacteria and virus, we can see them with the microscope. So some are very big and some are small, and the others are very micro in nature. We cannot see with our naked eyes. We require a microscope to see such things. Okay. And some things are living, like birds, plants, animals, human beings are the living things. And some things are non-living things. Okay, like sand, stones, bricks, they are the non-living things. So what is the matter? Things in the world, whether living or non-living things, are made up of matter. So all the living things and non-living things, we say it as a matter. Anything that takes up space and has weight is called a matter. Anything that has a that takes up space means which occupies the space as well as which is having the weight, it is called a matter. So matter has three forms. What are they? Solid, liquid, and gases. Okay. There are three states of matter mainly: solids, liquids, gases. So how we can recognize and how the molecules will be present in each type. Okay. Now let us see this. Molecules in a solid. See how the molecules means they are the small particles which uh, which makes the solids, okay, liquids, and gases. So which are present in that, the tiny particles. Okay. So molecules in solids, they are very tightly packed. In the solids, the molecules are tightly packed. For example, see, this is a pencil. Okay. What is the state of matter of this? Yes, it is a solid. So many molecules are present in this pencil. Okay. So what is the intermolecular space which is there between the all the molecules? So the space which is between the molecules is very less. They are tightly packed. So that's why it is in a solid form. The molecules, they are tightly packed. That's why they are in a solid form. So we call it as a solid. Next, see the molecules in a liquid. They are loosely packed. See the distance. For the solids, they are closely packed, the molecules. Here for the liquids, they are loosely packed. Next, see in a gaseous form, the gas, how it will be, the molecules will be more, they are more spread over. Okay. So the intermolecular space, it is more. Okay. For the solids, the intermolecular space is less. For the gases, it is more, means they are distant. Okay, you can see in this picture. For the liquids, it is somewhat less, and it is when compared to that of gaseous form, the distance is more. Okay, now let us see the next one. So matter is made up of tiny invisible particles called molecules. So matter is made up of molecules, we said. So what are the molecules? Molecules are nothing but they are the very tiny particles. Okay. And a molecule is the smallest unit of substance. A molecule has all the properties of the substance. For example, a salt molecule is the smallest piece, that is still salt. Okay. So for example, if we'll take the salt, so what are the molecules which are present in the salt? The each and the smallest piece, that is called its molecule. Or if you take the example of a sugar, what are the sugar molecules? All the tiny particles, that is the small the crystal, okay, of the sugar, that is called its molecule. Okay, like that. And what are the molecules made up of? A molecule can be either broken down into smaller units called atoms. So what are the atoms? The molecule can be further broken down into a smaller units called the atoms. Atoms are the building blocks of matter. All kinds of matter in the world is made up about 119 kinds of atoms. So what is an atom? Means, as we said, the matter consists of the molecules. And what are the things which are present in that molecule? The smaller units, they are called the atoms. Okay. More about molecules. The book you are reading now, the chair you are sitting on, okay, and the water you drink, the food you eat, are all the matters made up of molecules. So what are the solids? As we said that the molecules are involved in each and everything. That is, it is present in the solids, it is present in the liquids, and it is present in the gaseous form. Okay. So the chair you are sitting on, so it is a solid in nature. Okay, and the molecules are present in that, and the water which you are taking in, and the food which you are taking. So all those consist of the whatever the matter is there in that molecules are present. Okay, then why is the book a solid and water is liquid? Okay, so all these things consist of the molecules. So what we said, matter is nothing but it consists of the molecules in it. Now water is having the molecules in it. Okay, and the food which we are eating, it has the molecules. The table or the chair, if you take, they also have the molecules in it. But why we are saying the table, chair as a solid? Okay, and the cool drink, okay, it is a liquid, or oil, we are saying it as a liquid. So why we are saying that as a solid and that is a liquid? Now let us see. Then why is the book is a solid and water a liquid? Okay, so in the book molecules are present, and in the water also molecules are present. Then why we are saying the book as a solid and the water as a liquid? Now let us see. It is because the book and water have different kinds of molecules which are arranged differently. Okay. So why we are making the difference? Why we are differentiating it as a solid and it as a liquid? Okay. So why? Because the molecules which are present in that, they are arranged differently. It means that what we said, the intermolecular space in the solids, okay, it is very less. They are tightly packed, isn't it? And for the molecules which are present in the liquids, they are loosely packed. So depends upon that. We are differentiating that as a solid and a liquid. Okay. And look at the pictures. On picture on page number 44. Okay. In solids, the molecules are very close to one another. They attract each other with a great force. Okay. And the molecules are very close to one another. They attract each other with great force. So a solid is hard, has a definite shape and definite volume. We can hold it. In liquids, the molecules are not closely packed. Okay? The molecules are not closely packed. The attraction between the molecules is less. They can move about freely. That is why liquids can flow. A liquid has a definite volume, but it has no definite shape. See, the liquids, they have the volume, means when we measure it, it has some weight, but it doesn't have a definite shape. For example, see, a liquid has no definite shape. It takes the shape of the container. Okay, so when you pour water on the ground, will it be there like that only? No, it keeps on moving. Okay, so liquid, they doesn't have any definite shape. Okay, see, if you are taking the pencil, we can say the shape of the pencil. So it will be straight like this long. Okay, so we can say the definite shape. Okay, but for the liquids, they doesn't have any definite shape, but they have the volume, means we can measure that weight. Okay, and takes the shape of its container. A bottle of milk will be 500 ml whether it is in a bottle or a sachet, but it will change its shape according to the container. So whether it is in a bottle or a sachet, if you are taking the 500 ml of the milk, okay, so the weight will be the same if you take that in a packet or if you take that in a bottle. Okay, so but the only the when you pour that in a special container, it takes the shape of the container. That's it. But the volume doesn't change. Okay. In gases, the molecules are separated by empty spaces. They have a lot of freedom to move. So the molecules in the gaseous form, they can move freely. So the intermolecular space is very, it is a distance. Okay. The intermolecular space is more. Okay, the space is more for the gaseous form, but for the solids, the intermolecular space is very less. They are tightly packed. So what you have to say, the molecular space in the solids, okay, it is very less. So a gas does not have a definite shape or a volume, so they can move freely. So if they are start moving freely, they doesn't have any definite shape. If they are tightly packed, we can have the shape. If they are loosely packed, we can't assume the shape, isn't it? So this is about the solids, liquids, and gases. Next, let us see the solids in liquids. How the solids will act in a liquid. Some substances like salt and sugar are soluble in water. The molecules of salt and sugar find space between the molecules of water. A solid that dissolves in a liquid is called a solute. So now let us see what is a solute, what is a solvent, and what is a solution. A liquid in which a solid is dissolved, it is called the solvent. When a solute dissolves in a solvent, it is called the solution. Okay. So when you take the sugar, what it is? It is soluble in water. So a solid that dissolves in a liquid is called solute. So sugar is a solute. And what you are taking? Water. So that will solve that. It means it is a solvent. Okay. The solute, you will, who will solve the solute? The solvent. Okay, the solvent will absorb that. So it is called the solvent. When a solute dissolves in a solvent, we get a solution. So when you mix up the sugar in a water, if you take the water and the sugar, and if you mix the sugar in a water, then it becomes a solution. Okay. So, and what the sugar is called? Solute. So, which you are mixing in the water, it is called the solute. And in which you are mixing that, that is called the solvent. It is solving, that is called the solvent. So, water is a solvent, sugar is a solute, and the sugar water is a solution. Is it clear? So sugar is a solute, and which is solving that is called solvent, and the sugar water, which is in a mixed form, that is called the solution, right? The water in which the salt is mixed becomes salty in taste. For example, if you take the salt, what is the salt again? It is a solute, and the water solvent, and the salt water is the solution. So same is the case with the sugar. The water in which sugar is mixed acquires the property of sweetness. So after mixing that, you can assume you can have the taste of it. Okay. So if you mix the salt in the water, salty water. Okay. And if you mix the sugar in the water, the what is the taste of that? Sweetness. But the volume does not increase when you pour the sugar. Okay, when you put the sugar in the water and mix it, the volume does not change. Why? Because in the liquids the molecular space is more, okay, when compared to that of the solids. So the sugar particles, they will occupy that space, so the volume does not change, right? Now let us see. Take a few crystals of potassium permanganate, put them to a beaker of water, see how the color spreads. It is soluble in water. As this experiment we have in our fourth class also. So take a few crystals of potassium permanganate, and when you put that potassium permanganate, see in this picture, in the water, the color will get changed. Okay, and put them in a beaker of water, see how the color spreads. So by seeing that, we can say that the molecules which are there, they are present in that. Okay. So when you mix something in a liquid, it gets into the spaces between the molecules to form a solution. Liquids such as spirit, alcohol, glycerin, and milk dissolves in water. They are called miscible liquids. Some liquids like oils do not dissolve in water. They form a separate layer and flows on the surface of the water. They are called immiscible liquids. So immiscible liquids and miscible liquids. Miscible liquids and immiscible liquids. So what does it mean? The things, okay, the liquids which are they absorbed in the water, they are called miscible liquids. Okay, and the liquids which does not dissolve in the water, which floats on the water, they are called immiscible liquids. For example, if you mix up the kerosene or petrol in a water, will they absorb in the water? No, you can see on the water, the top layer, there will be it is in a greasy form. Okay, so they are immiscible liquids. Whereas the spirit, alcohol, glycerin, okay, milk, when you mix the milk in a water, it changes into a milky water, isn't it? So there is no separation of that. You can't see any separate. So the milk won't be float on the water, isn't it? It is mixed in the water. So they are called miscible liquids, where the things, that is the oil, petrol, kerosene, they are not mixed in the water. Okay, they are floating on the water on the top layer. You can recognize that greasy form. So they are immiscible liquids. So this is about the how the liquids change its uh, form when they are mixed in the water. So we have seen the solids, how they change when they are mixed in the water. Now we have seen the how the liquids changes when they are mixed in the water. Now, how the gaseous form will be there? Okay, when it is mixed in the water, that we will see in the next session. Meanwhile, all of you go through the lesson, whatever we have finished till now. Okay, children?